Well, the holidays are over. Not quite. I mean, not quite, at least at the time this is being filmed. But Intel has saw fit to release a new CPU, the Intel 7th generation CPU, also known as Kaby Lake. We're taking a look at the MSI Z270 XPower gaming, because maybe you're thinking about building a system, or maybe you're thinking about this particular motherboard. We're going to go through the ins and outs, go through the Uefi. MSI has really turned it up to 11. No, really, they added a knob to the motherboard that lets you turn it up to 11. It actually goes up. It goes from 0 to 11. You literally turn it up to 11. There's a knob. There's an actual knob on the motherboard. Fine, I'll show you. I don't know. Oh, a lot of motherboards. There are a lot of Kaby Lake motherboards. This one is the titanium. The box is titanium. The motherboard is titanium. And I don't know if you can really see it on the camera, but the printed circuit board for this motherboard is a really nice sort of metallic, glittery, I don't really know how to describe it. It's silver, but it's sort of silver fleck or like silver two-tone paint. It actually looks pretty good. I think this might be a little weird inside a white case, but inside a black case, especially if you did something with the lighting. I mean, this motherboard is made to be shown off. I think also the name titanium sort of reminds me that if I'm ever put in charge of naming a motherboard, I'm probably not going to be very good at it, because I would want to name the motherboard something like molybdenum or, you know, americium or something. But no, titanium. We'll go with titanium. Titanium. That's pretty cool. So what are the features of this board? Well, it supports Intel 6th and 7th generation CPU, so we're talking about Skylake and Kaby Lake. So if you wanted to get a 7700K, for example, or the i5 version of that, you totally get that for this particular motherboard. It's based on the Z270 chipset from Intel. 4 DIMM slots, you know, pretty standard fare. Z270 is really an update for Z170. If you want to learn more about Z270 in general, there's a Kaby Lake platform update. You can learn more about the CPU. If this is your first time building a system or something like that, I suggest you watch that video first for the link in the description. But if you want to learn all about this particular motherboard, that's what we're going to go into for this video. So let's dive right into it. Now, if you notice on the motherboard, everything is metal reinforced in addition to having this sort of silver fleck finish. Now, the silver fleck finish is around the I/O shield. It's sort of on the VRM Heatsink Assembly and all of that, but the RAM slots are also metal reinforced, and it has 4x16 physical PCI Express slots that are also metal reinforced. Now, when I see this many PCI Express by 16 slots on this platform, it always gets me thinking, because Z270, the chipset, has 24 PCI Express lanes, so that's to be shared among all the peripherals. But when we're talking about, you know, the socket 1151 6th and 7th generation CPUs from Intel, Core i5, Core i7 CPUs, they really only have 16 lanes for the graphics card, or 16 direct PCI Express lanes into the CPU. And then there's something called the Dmi interface. The Dmi interface is about 4 PCI Express lanes worth of bandwidth. And so the big difference between Z170 and Z270 is that they added 4 more PCI Express lanes, but the interconnect to the CPU is not really any faster. So even though the motherboard has all kinds of PCI Express connectivity, if you get really high-speed peripherals, it'll still bottleneck that DMI interface. But this motherboard is interesting because there are 4 PCI Express by 16 lanes, and so it's like the first question that pops into my head is, well, what's the layout on that? And it's by 8, by 4, by 4, by 4. And I know what you're thinking. All those 4s go through the DMI. No. The other configuration you can have is by 8, by 0, by 8, by 4. So the bottom slot is always through the DMI, but that second slot from the bottom is by 8 directly into the CPU, or by 4 directly into the CPU. And so your second slot is by 4 directly into the CPU as well. So when you're populating cards on this motherboard, you want to skip that second slot unless all of your other slots are already populated, because putting something in that second slot is going to cause your PCI Express lanes to drop down to by 8, by 4, by 4, by 4 in this layout. MSI has helpfully also offered a dip switch that you can configure on the motherboard to explicitly set the PCI Express layout that you want in case you're juggling a lot of peripherals. This motherboard also has 3 M.2 slots. It comes with 1 M.2 shield, which you can see here. You can remove that. You don't have to use it. It's optional. But if you're going to use it, you know, the manual says this can help with heat dissipation issues. And so if you are in a situation where it's like you're gonna run one of the really hot M.2s, you could use that to maybe help with the heat dissipation. Although I would have liked to have seen an included thermal pad or something like that if you're gonna use it for that purpose. But you don't have to use it. If you think you're gonna get, you know, better mileage out of not covering your M.2 and getting better airflow, you totally don't have to use it. But it does look pretty swank, I guess, so there's that. Also included in the box is this OC panel. This OC panel up here gives you some controls in terms of reset, power, overclock, and that sort of thing. Now the OC dashboard, you can just mount directly on the motherboard, but there's also a cable that you can run this OC dashboard pretty much anywhere you want. So you can plug the cable into the motherboard and then plug the other end of the cable into this OC dashboard. So you can have it hanging out the side of your machine or the front of your machine or wherever the cable will reach. And it gives you some controls for increasing the voltage, overclocking the CPU, that sort of thing. This header here is designed for a multimeter readout, so you can read the voltages directly from the CPU. It also has a 16-phase power delivery system. So this is a really extreme configuration that MSI has gone for in terms of power delivery. But I'll tell you, in my own testing, you know, with Kaby Lake, it's not really about power delivery on the overclocking anymore. It's really about controlling the thermals. And so for my own testing, you know, motherboards that have a relatively modest power delivery system, we're still able to hit that sort of magical 5 gigahertz overclock with the chips that we have that actually do overclock to 5 gigahertz, even without having an overly elaborate voltage regulation system. So the voltage delivery circuit on this is designed with 16 phases in mind, which, good Lord, that's probably overkill for Kaby Lake, but MSI is shooting for the top end with this motherboard. So I think even if you're doing extreme overclocking with like a refrigeration pump or liquid nitrogen, you should be able to deliver more than enough voltage to cause your CPU to crater. So that's nice. So the overclock knob, what's up with that? You can turn it up to 11. Yes, that is a Spinal Tap reference. The knob is sort of interesting. So MSI's approach this time is they're basically saying, look, Kaby Lake is basically a tweaked and improved Skylake. So I think we can get away with a table of overclock profiles that generally work with different CPUs. And so I was talking to the guys from MSI, and they were saying, like, for example, the manufacturing process on certain kits of memory, like the Corsair kit of memory, like Vengeance, for example, you can tweak the parameters to those specific memory kits and 85–90% of the time achieve an overclock with that memory kit even beyond the specifications. And memory is notoriously tricky to overclock, which is why the whole XMP profile thing was created, to make it easier to be like, look, we're going to say that these XMP profiles work most of the time, even though Intel doesn't really want you to run memory faster than 2133 and now 2400. So what this knob does is pick from presets depending on what your CPU is. So if you got an i5 or an i7 Skylake or Kaby Lake, either one, you can use this knob to pick from presets. Now the manual actually has a full breakdown of what each preset is going to try with your CPU, but you can basically set it and it'll try that sort of known good preset that works with certain variations of the CPU. Now that may sound like black science, but you know, even going back, 50 generations, once upon a time there was something called the Celeron 300A. And so the Celeron 300A, if you got one from Malaysia, the thing would go, it would overclock so much that it was just completely insane. Like, think of, like, if you got a 3 gigahertz chip, you could overclock it to 4.5. Now, if the CPU is much slower than that, we're talking like 300 megahertz. But you could go from 300 megahertz to 450 megahertz. But if you got one from Costa Rica, well, you weren't so lucky. You would be lucky if the one that was 300 would hit, 380. So it just depends on, which fabrication facility it came from and a whole bunch of other variables. Well, Kaby Lake is just like that, except, a whole lot more modern and a whole lot more variables, because we're talking about a whole lot more interconnects and a whole lot more pins. And so what MSI has done is loaded a table in the Uefi of all of the presets that work with all of the different CPUs that they've encountered in their testing. And so they're like, well, if you're really lucky, this one should work. If you're really lucky, this other one should work. And so there's basically 12 different profiles, because it's 0 to 11, that you can pick from with the knob, and it'll change all of the variables for you, so you can just use that for your overclocking. Now, in general, a decent CPU on Kaby Lake will hit 5 gigahertz, but that's from not a lot of testing. And also, when you get your motherboard, you're going to want to update the Uefi. That's all. It's been true for like 2 or 3 generations now. You're always going to want to update your Uefi as soon as you get your board. But it looks like that the Kaby Lake i7s are gonna generally hit 5 gigahertz 50% of the time or more. So unless you get a dud CPU, you know. Now the stock speed, 4.2 gigahertz, turbo to 4.5. It's not really that much of an overclock to go from 4.5 to 5, but 5 was very difficult to obtain on, you know, Skylake. So 4.5 on a Skylake, basically you were doing pretty good. 4.4, I would say, was more typical, more the norm, again, for the i7 part. But this CPU frequency thing has a table for both Skylake and Kaby Lake, and you can use Skylake and Kaby Lake CPUs both in this, so Intel 6th and 7th generation CPUs. It's a pretty neat way to approach overclockability and make it more accessible for, you know, lots of different people. So I thought it was a neat feature. All right, let's take a look at our back panel. At the top here, we can see we've got our red PS2 port. Now this is for people like me that still use a Model M PS2 keyboard or other high performance PS2 keyboard. Then below that, we've got two USB 2.0 ports, a clear CMOS button, and then this port is for something MSI calls BIOS Flashback Plus. Basically what this is functionality where you can put the BIOS for the board on a USB stick, plug it in there, and even without having any CPU installed, you can update your BIOS. This is sort of the climate that we're in, you know, with Intel, with the X99 refreshes, you know, we've got Broadwell E. It was possible to buy a Broadwell E CPU, but then have a motherboard that won't boot with that CPU until you update the BIOS. Unless your motherboard has some kind of an update mechanism like that, you're stuck. You'd have to put in an older CPU in order to be able to update the BIOS. So you'd have to send your motherboard back, or you'd have to call your motherboard manufacturer and they would send you a new BIOS chip to physically install. So this board actually has two BIOSes, an A and a B BIOS, and there's a physical switch to switch between them, and you can flash those BIOSes using the USB stick. So you've got quite a bit of redundancy and resiliency there in terms of a flash gone wrong, in terms of future CPU updates, that kind of thing. We're dealing with the same sort of refresh here with Z270. You know, this motherboard will work with a Skylake or a Kaby Lake CPU. Most motherboards, the Skylake CPUs like Z170, will work with a Kaby Lake CPU, but it will require a UEFI update. So if somebody's buying an older motherboard because they're on super sale and they don't care about USB 3.1, they don't care about the extra PCIe lanes, then it could be a situation where somebody buys a Z170 motherboard and a Kaby Lake CPU and can't boot it until the BIOS is updated. So having this type of functionality is really important to be able to make sure that you've got the latest and greatest CPU support for your motherboard and the latest and greatest for the UEFI. Then next to that, we've got our two LAN ports. These are both Intel gigabit NICs. Then we've got our Z170 provided USB 3.1. That's right, the Z270 chipset provides USB 3.1, which is 10 gigabits per second, on these four USB ports. Then we've got DisplayPort and HDMI, which are wired into the iGPU on the Kaby Lake CPU. Then we've got USB 3.1 Gen 2. These two ports are through an AS Media controller. You've got one Type C and one Type A. This USB 3.1 Gen 2 Type A is also something called VR Ready from MSI. So it's got better power delivery, better power isolation for USB devices. Some VR headsets are USB powered. In terms of power delivery, you know, glitch-free operation, because the power delivery system can keep up with those VR headsets that may drink the power. And then we've got our gold-plated audio ports with our optical SPDIF out port. And so MSI's implementation of the Realtek codec is called Audio Boost 4 with Nahimic 2. This is 120 dB signal-to-noise ratio implementation. It does have an isolated PCB, gold-plated fittings, you know, the whole 9 yards. So if Nahimic is something that you're looking at, Nahimic is implemented on the board. Now at the top of the board right away, we can see that we've got our 8-pin CPU power plus an auxiliary 4-pin CPU power. Again, 16 phases. This thing is built for power delivery. Holy crap. Then we've got our CPU fan header and our pump fan header. The pump fan header is designed for high current delivery for a water pump, and you can control the PWM. There's a button just above the RAM, which is the BIOS flashback button. So you can hit that button on the motherboard to initiate the BIOS flashback process. Basically, all you do is rename the BIOS file to msi.rom on your FAT32 formatted USB stick, and you're good to go. Now, the steel reinforcement on the RAM slots is an interesting implementation on this motherboard. The RAM slots actually sort of sit in a chrome-plated, you know, metal tray. It's not really that the metal is a part of the slots themselves. It's just metal isolating the actual slots themselves. So I think I like this better because, you know, when I've had a system that's been on for a long time and it's got a lot of dust and crap and junk, the dust and debris will accumulate between the RAM slots. On this motherboard, that wouldn't be possible. It's occupied by this by this metal shroud thing. So I think that's probably good in terms of long-term health of the system. You've got your 24-pin ATX power connector, another 4-pin fan header. We've got two 6 gigabit per second SATA ports below that. Then we've got our front panel USB 3.1 connector, our first of two. Below that, we've got 6 more 6 gigabit per second SATA ports. Then we've got our turbo U.2 connection. Notice there's no SATA Express here. Then we've got another 4-pin fan header. In the front corner of the board, we've got all of our connections. For the front panel, our BIOS switch selection, so we can pick between an A and a B BIOS, and some other miscellaneous inputs. We've got our front panel header next to our physical power and reset button. Then we've got the game boost knob that I was mentioning before. Next to that, along the bottom edge of the motherboard, we've got our second USB 3.1 header. Now, one of the USB 3.1 headers is powered by the Intel integrated chipset, and the other USB 3.1 header is powered by an ASMedia controller. So you'll have both ASMedia and Intel USB 3.1 connections on the front of your case. You should note, however, that not all cases have a USB 3.1 capable set of ports. The specifications have changed with USB 3.1. The connectors on this motherboard have not. Some other motherboard manufacturers have implemented different connections for USB 3.1, so you can be assured that your front panel USB 3 is USB 3.1 compatible, USB 3.1 certified, ever how you want to look at that. But these ports are USB 3.1, and if your case is USB 3.1 compatible, your ports will run at USB 3.1 speeds. But if it's not, it will back off to USB 3.0 speeds. So just keep that in mind. Then next to that, we've got two more USB 2.0 headers. We've got our dip switches. Now these dip switches control the PCI Express arrangement layout. Now there's a full diagram in the manual, but I really appreciate that they've included a little diagram on the motherboard just above the bottom M.2 slot that has sort of the configuration that you're going to get for the non-primary PCI Express slots. Then we've got a diagnostic code readout LED, and there's a handy table of diagnostic codes in the manual. Then we've got our RGB pin header, another 4-pin fan header, and then our isolated front panel audio. And then I can see the little Nichikan audio capacitors peeking out from behind the metallic audio shroud. In addition to the 4 PCI Express by 16 physical slots I mentioned before, there are also 2 PCI Express by 1 slot. So in case you want to add in, another NIC or a wireless card or something like that, you totally can. Just above the primary PCI Express by 16 slot, you'll also find your CMOS battery, another 4-pin fan header, and 6-pin PCI Express power input. Now, if you're really going to run 4-way crossfire on this motherboard, which you totally can do, then I would strongly recommend that you supply extra power to the motherboard through this 6-pin connector. But in most configurations, if you're just running a single graphics card and a peripheral or two, you don't really need it. If you want it, then it gives your motherboard a little bit extra power delivery headroom for your expansion cards, so you can totally do that. The heatsink assembly for both the voltage regulation circuitry and the North Bridge is sort of a nice two-tone dark brushed aluminum and sort of silvery metal paint fleck finish. It actually looks really nice, this black and silver. My gut is that this motherboard would look best in a black case versus a white case. But hey, if you decide to do a build with this and you do it in a white case, definitely post pictures on our forum, because I'd be real curious to see that. The voltage regulation circuitry also has a heat pipe between the primary and secondary heat sinks. If you're going to use an all-in-one closed loop cooler with this setup, I would strongly recommend that you have some type of airflow, some type of a fan blowing across the motherboard, just so that you get some airflow around the CPU socket. Right next to the 6-pin power, you can also see the VR boost cover, which is part of that, enhanced VR experience. It's part of that ASMedia USB 3.1, delivery system. I don't usually talk about the back of the motherboard, but the same sort of metallic silver finish continues onto the back of the motherboard. It is really interesting, I have to admit. And then you can also see the RGB LEDs along the gaps in the printed circuit board next to the audio solution, because the audio solution is on that isolated part of the printed circuit board. Next up, we've got a tour of the Uefi. So we've turned it up to 8. Can't turn it up to 11, but maybe with a good all-in-one closed-loop CPU. But I've turned it up to 8, and I've already done all the operating system testing and that kind of thing. I've just got it on my test bench now, so that I can do a little recording of it so that you guys can see what the Uefi looks like. 5 gigahertz, 2933 memory. Z270 XPower gaming titanium. 1.382. We're at 51 degrees C. Now this is with it's a different cooling setup than I normally have. I really strongly recommend an all-in-one or custom loop cooler, not air cooling. Although, if you're going to go air cooling, get something that's a top-end air cooler. So we've got our Corsair Vengeance DDR4 3000. This is one of the fastest kits that I have right now. I think DDR4 3000 and 3200 are the top end kits that I have. And it works pretty well. So on this fan profile, 55 degrees C is equal to about a 38% fan profile. Let's go to the hardware monitor. Now in here we can set smart fan mode. We can set DC or PWM on fan 1. We'll just set everything to full speed. CPU 1, PWM DC auto. Pump 2, CPU 1, PWM or DC. Pump 1, PWM or DC. You can also control the fan step up and step down time. System 1, System 2, System 3, System 4. So you get 6 fans, DC or PWM control, and you can monitor the CPU temperature or the system temperature. Right now my CPU is at 53 degrees C because, well, we're running at 5 gigahertz. That's an i7 7700K. We can see here in the Uefi that my hardware switch is set to 8. Now this reports XMP off, but the memory profile that we have is very close to the XMP profile of DDR4 3000. So I think that's just a side effect of the overclock. I'm not sure if that's a bug in the BIOS or not. Let's go to F7. Okay, this is a little more familiar. This looks like what I'm used to seeing in sort of an MSI Uefi. Let's go into overclock settings. OC Explore mode, expert, beta. Turn the beta function on. That sounds interesting. CPU offset when running AVX by default is -4. That's a pretty safe value from the limited experimentation that I've been doing so far for this much of an overclock. Game boost function by onboard button, ratios auto. You know, I'm using the inbuilt GPU right now as well. If you're using an add-in GPU, you can disable the built-in GPU, and you may be able to achieve a little bit more stability with your overclock because the iGPU, I think, is a little bit more sensitive to overclocks than the built-in CPU. Base clock at 100 megahertz. Now, this is something that you can mess with on this motherboard if you want to try to run, 110, 115, 150, whatever for your base clock, and then back it off on the multiplier if you want to do that. Did not have enough time to test all of those different configurations. Now see, this says extreme memory profile disabled. I'm going to go ahead and enable that because I don't know. So yeah, okay, so that's just going to take it, the little thing that flashed up there said that my RAM speed is basically not going to change because I guess the button already did that. And so this gives you a little preview of the sort of speeds that you can expect. So I could do 30 times 100. So this is actually wanting me to run by 1.33 instead of 1.0. It's interesting. We'll leave it that way. Memory try it can improve memory compatibility or performance by choosing optimized memory preset. So this will let you change your memory settings only and reset your memory settings only when you're doing overclocking to do testing. Interestingly, the manual for this specifically called out some Corsair kits that you can overclock with just a little bit more voltage, and in experimentation here, I've tried it and it works. Then of course you've got your advanced DRAM configuration. Wow, this gives you a lot of options for DRAM phase control, CPU SA phase control. VTD is disabled by default. I'm going to enable that. C state, because I'm overclocking, I'm going to leave that disabled. Memory Z, built right in. Cool. You can also get the XMP profile. CPU specs, 4 cores, 8 threads, CPU stepping 9, 8 megs of cache, 5 gigahertz. Microcode version 42, which actually is going to be updated momentarily. By the time you guys get this, you will have to update the Uefi. I can just tell you now, especially if you're an early adopter, when you get one of these, just plan on updating the Uefi. Gonna have to do that. OC profile, hardware monitor. We were in the hardware monitor before. Board Explorer, yeah, I don't have anything installed right now except for the RAM. You can see that. This is a really handy feature. This Board Explorer type stuff, this is really handy. Basic system configuration, DMI information, controlling the latency timer, and the max PCI Express speed. Now sometimes you do have to set the max PCI Express speed, especially when you're mixing your GPU with other add-in peripherals. On several boards that I've got a PCI Express Gen 2 capture card, and if I'm using the PCI Express bandwidth into the CPU, I will have to explicitly set Gen 2 for the expansion slot in question, because Gen 3 is what it defaults to, and if I do that, multiple graphics cards, it shows up like as if there are multiple graphics cards. It's really an interesting situation. Internal serial IO, yeah, RS-232 port. I should do a video about the emergency management console in Windows and setting up RS-232 serial port on Linux so that you guys can use RS-232 from, whatever. iGPU multi-monitor. If you're going to use an add-in graphics card and the built-in graphics card, you'd want to enable this so that you can run even more display outputs. But for most people, disabled, probably a good thing. especially on overclocking, because the iGPU is harder to overclock. Well, it's not harder, it's just that the iGPU can introduce unnecessary instability if you're not going to use it. MSI fast boot. And here's our i219V. Can blink the LEDs. And it's not plugged in right now, which is correct. Let's save and exit, because I turned on extreme memory profile, and let's see if that makes any difference in our memory speed. And we're in 2933, and now XMP is on. Neat. Well, that's been a quick tour of the Uefi on the MSI Z270 XPower Gaming Titanium, or the MS7A58. Ah, lovely Fedora on the MSI Titanium. Let's take a look and see if all the devices are detected. Well, I can confirm that the audio is working correctly, so that's good. I can see that both of the Ethernet interfaces were detected correctly as well. Here's the output of LSPCI in case it's useful for anyone, and here's the output of IOMIM. So these buttons on this OC dashboard, what the heck do they do? Well, the printed circuit board is labeled, but it's very tiny. The two buttons that are on the left will increase and decrease the base clock. There's a slow switch on there as well, so you can flip the slow switch and it'll put everything back to slow mode. You've got reset and power. Then next to the power button, we've got a discharge button. What does the discharge button do? Well, with modern ATX power supplies, there's something called standby power. So even when your computer is off, unless you've got the mechanical switch in the back off, there's some stuff that's still on in your computer. It's waiting for you to hit the space bar, or waiting for you to hit the button, or whatever. So when you physically turn that rocker switch off, your computer will stay on for a second. You can press this discharge button and make that process happen quicker so that you can reset the BIOS more quickly in that scenario, so that if you're trying a whole bunch of different settings and something doesn't work, and then it's like, okay, I need to reset the BIOS, and you got to wait for the standby power to go off before you reset the BIOS. Well, when you press the discharge button, it'll discharge immediately. So it's handy if you're resetting your BIOS about 50 times a minute. So, and you might be doing that when you're trying to figure out the absolute maximum stability that you're going to get out of something. So I have been annoyed by that in the past, but MSI has given a button for that. So it's pretty cool. I think that that might be more useful for people on like liquid nitrogen, but hey, it's there if you need it. And then we've got two more plus minus buttons, but instead of controlling the base clock, these actually control the ratio. So you've got plus minus control of both the base clock and the ratio, depending on what your CPU likes to overclock more. You know, in the past, before Skylake and Kaby Lake, it was definitely the case that on some CPUs, you could hit a much higher clock speed by having a lower multiplier, but a higher base clock speed, which is really interesting. So Kaby Lake is brand new. Haven't really had a lot of time to play with it. Don't know what the future is going to hold in terms of overclockability. But in terms of overclockability features, it seems like MSI tries to really give you a lot here. So then the question becomes, what do we actually get? How does it actually work? Well, I've got an i7 7700K. We actually ended up having 3 CPUs to test with, one of which we just got 12 hours ago, because some retailers have been fast and loose with the whole, like, oh, should those not be on sale yet? Whoops. And so you can, if you buy a laptop or something, you've been able to get a Kaby Lake CPU for like forever. But the desktop CPUs were supposed to be under embargo until January 3rd, but you could even, like, you could find them on eBay, and some retailers sell them, some OEMs had sold them. So we got 2 Core i7 7700Ks, one of which is a loaner, and we got one i5 7600K. So we got 3 CPUs, which is admittedly not a huge sample size, but can we turn it up to 11 with this CPU? Well, we did the testing, and no, we can't turn it up to 11. 11 in this case on a 7700K would have been 5.2 gigahertz on the clock speed. Can't do. But we are able to turn it up to 8. 8 is 5 gigahertz even on the 7700K, and if you have a 7600K, the 8 setting on this dial is 4.7 gigahertz. So yeah, 5 gigahertz. All I had to do was turn the knob. But that's not the most surprising thing. The most surprising thing is this Corsair Vengeance memory. So this is DDR4 3000. This is a standard kit, came from Micro Center. And the DDR4 3000 kit, it actually works at 3333. And the MSI thing was just like, yeah, we just do it, turn it on, whatever. And it's like, okay, sure. It's like, I think I can get this to 3333. And it's like, all right. And it did, and it was fine. Now, I don't know what voltage it was pumping in there, or if that was just a result of the increased voltage to the i7. I haven't had Kaby Lake long enough to really figure that out. But yeah, it actually worked at 5 gigahertz, and it was stable enough to run several different benchmarking programs. Although I think with AIDA64, I'm gonna have to, I had a crash with AIDA64 in one of the runs, and I think I'm gonna have to back off the AVX instruction. So there's a setting in Uefi to back off your AVX stuff a negative multiplier or two, which is a great feature to have. The negative multiplier functionality helped me tweak the stability just a bit. So you can override the settings, like the presets that you get. So when you set it to 8, it'll just load those into the Uefi, and then you can go sort of tweak it from there. And that's what I did with the AVX to back it off just a little bit. But for everyday things, 5 gigahertz is fine. In the box is a license for XSplit 2, version 2. It's a 1-year license. And there's also a nifty USB 2.0 hub printed circuit board. So there are some USB 2.0 port headers on this motherboard, and you can run that out to this hub, and this will give you 4 more USB 2.0 port headers internally. And so I figure that MSI is looking at this and they're saying, this board is for an enthusiast. It's for somebody that's going to show it off. I mean, obviously with the silver coloring and the metal fleck paint, I mean, you pretty much would have to get a side window for this case. I mean, come on. And people that are running that are running all-in-one closed loop coolers or custom loop coolers and, you know, fancy power supplies. And a lot of those devices these days have their own USB interfaces so that you can control them better through software, RGB, you know, fancy RGB, even though it does have a built-in RGB header. You know, people are getting fancy with like internal displays on their thing. And so there are a lot of peripherals these days that internally have USB 2.0 connections. And so MSI is saying, well, you know, rather than put more USB 2.0 ports on the board, these devices really don't use a lot of USB 2.0 bandwidth. Let's just give you a breakout board that actually lets you use more internal USB devices. So if you do have a power supply and, you know, a couple of, you know, a closed loop cooler for your graphics card and your CPU and, you know, maybe a USB display or USB, you know, LED controller that's like, you know, fancy, moves with the music or something, then you can plug all of that in to the one USB hub, route the cables however you want, and keep the motherboard really clean. It's a nice touch. Also in the box, the included Sata cables have been themed the same titanium. So MSI has really paid a lot of attention to detail in terms of like the bundle and the stuff that comes with the motherboard and following the titanium theme, which is really nice. If you end up with one of these or you're thinking about getting one of these, please do head over to the forums. We just released a ton of videos all about Z270 motherboards. There's like 50 of them. Hopefully you watch all of them. There's a link to the playlist in the description. Hopefully, fingers crossed, we remember to do that. So, you know, if you're shopping for Z270, you're shopping for Kaby Lake, you're looking for something out there, be sure to check out our intro to Kaby Lake, which covers a little bit more questions about the platform and that other stuff. If you have questions, come to our forum. We're nice, we're friendly. It's a pretty cool place. There's a lot of really cool people there. Thanks to everybody there helping everybody answer the questions. You are the unsung heroes of this operation. So I'm Wendell, I'm signing out, and I will see you in the forums. As it turns out, I like to hang out there. See you guys.